Hello, today we are going to review sequences and series, standards 2A and 2B. So before we get started, what I want to remind you of are 3 question stems that will help us to answer every single sequence question. So what is your starting term value? How is your sequence changing? And how many times do I need to move? Those are the 3 questions that really helped us for sequences. Then below I have the formulas that are provided for you on the assessments for series. So if I go to the first question, given a geometric sequence with a sub 4 equals 72, that means that the 4th term in the list is 72, and a sub 7 equals 9, so the 7th term in the list is 9. Determine the common ratio. Okay, so let's start by asking ourselves the questions. What is your starting term value? 72. How is your sequence changing? I do not know. That is what I will look for, the common ratio. And how many times do I need to move? I will be moving 3 times. And how I think about that is if we are in a movie theater, you are in row 4, I am in row 7. How many rows do you need to climb over to get up to me? 7 minus 4 is 3. So that's what helps me out. I think movie theater when it comes to that question. And then that will equal 9. Go ahead and pause this video, see if you can solve for R. Okay, go ahead and check your solution. My common ratio is 1/3. So the pattern for the sequence is to multiply by 1/3. All right, looking at example 2, we have an arithmetic sequence where the 2nd term is 5 and the 8th term is 47. Determine the common difference. What is your starting term value? How is your sequence changing? How many times do I need to move? Again, I think movie theater, 8 minus 2 is 6. And that will equal 47. Please go ahead and pause this video and solve for your common difference. And when you solve, you should end up with your common difference as 7. All right, as you go to problem 3, you are given the rule that a sub n is 3 times 2 to the n minus 1 power, and a sub n is 1,536. Determine n. This is the circled problem on your notes. Please pause this video and attempt this problem, and your teacher will provide you feedback. Moving on to example 4, given the first term is 12 and the common ratio is 3, determine S sub 15. That means the sum of the first 15 terms. So when I'm looking up at the top of my notes to determine which formula I will use to find the sum of the first 15 terms, since 15 is a stopping point, there's a finite series, so that is the formula that I will use. So let's go back down. So the sum of the first 15 terms is the first term times 1 minus the ratio to the 15th power all over 1 minus 3. Now I want you to actually find your calculator, find it wherever it's hidden in your room, in your backpack, wherever it's at, and try typing this in. And my hint is in your denominator, use parentheses around 1 minus 3. Pause the video until you can find a calculator and type it in to see what you get. And if you can push buttons, you should figure out that the sum of the first 15 terms is 86,093,436. Alright, so going on to example 5, we have some summation notation. So looking at the rule that is written in my parentheses, I notice that that is arithmetic. How I know that is it looks like slope. I'm thinking y equals mx plus b. It just has different letters. There's an n instead of an x. So I know this is arithmetic. So when I'm choosing my equation for this arithmetic rule, I want the sum of terms 2 through 16. So my number of terms is first. So 16 minus 2 plus 1. There are 15 terms in total that I'm adding up. So I will have 15 over 2 times the first term. Well, since I'm starting at term 2, I need to figure out what is the second term using this rule. And the second term is 2. And then I need to figure out what is the 16th term in my list. So to figure out the 16th term, use that rule. 3 times 16 minus 4 ends up being 44. Go ahead, take a moment to pause this video, type this into your calculator, see what you get for the sum. You should get 345 as your solution. Moving on to example 6. Looking at this rule, I know it is geometric. The reason I know it is geometric, it looks like an exponential function and how it is laid out. So I know that to find the sum of something geometric, I need to know, is it going to be finite or infinite? And because of the infinity sign above your summation, I know it is infinite. So my first term goes in my numerator. So if I need to find my first term, take the rule, substitute in 1 for n, and you will end up that the first term is 4. Denominator, 1 minus the ratio. The ratio is the number that is in your parentheses. So I will put in a 2/3. And again, just like the last problem, if you are typing this into your calculator or doing it in your head, I would think of the denominator in parentheses to avoid any button pushing errors. Please pause this video, type it in, see what you get. You should get 12. Alright, last summation, number 7. I'm looking at this. It looks geometric and it is infinite. Next up, I'm looking at my common ratio, and ooh, this common ratio is 3. 3 is a number that is larger than 1, so this is our favorite kind of problem. There is no sum. The reason there is no sum, it's because the common ratio is larger than 1, which means that this diverges. All right, almost done. Go ahead and scroll to the next problem. Your blank for the next problem is 20%. Can you pause this video? I want you to read these directions, and I'm looking for the total number of views. See if you can read it and then write down your setup equation. Okay, a few things I want to look at before I talk about my setup equation is I notice in the problem that we are increasing by 20%. So right now, look at your setup equation. Is your common ratio 1.2 because you are increasing? Now let's go ahead and look at your setup. Do you have the correct parentheses? You have your 24 as your exponent up here, all of those things to check. And now again, pause, type in your calculator, see what you end up getting. You should end up with 33,361 views. Okay, last problem. Your blank is 42. I want you to do the same thing that you did above. I want you to pause this video, read the problem, and see if you can come up with a setup equation using the formulas that are at the very top of your notes. Alright, and reading this, because I'm looking for a total number of seats, I know this is a series. Since my pattern is 8 additional seats plus 8, it is arithmetic. And when I'm using my formula, the only thing that I need to actually find off to the side is what is the 42nd term, how I do that, what is your starting term value, how is your sequence changing, and how many times do I need to move. Once you have all of that, we can go over to our equation. And when I type this, when I type this into my calculator, you should get 8,358 seats.